In this problem, we are required to find the net current that is actually released into this circuit. And we are also required to find the individual currents that will pass through the 3 ohm resistor as well as the 7 ohm resistor. Now we are also required to find out what will be the loss volt as well as the terminal voltage within this DC circuit. Now first off, we know from Ohm's law that the potential difference is equal to the product of current and the resistance of the circuit. Now here we have two different types of resistance. We have internal resistance, which is actually represented as a smaller case r, which is over here. And we also have the external resistance, which actually is represented with an uppercase R. So if you have a DC source, in this case a battery, with an EMF of 20 volts, the Ohm's law is actually expanding into this. Now what this means is this is the loss volt while this is the terminal voltage. Now the loss volt is a product of the net current by the internal resistance, and the terminal voltage, that is the product of the net current with the external resistance. So if we wanted to find the net current, we just need to factor out I from this. So this is going to be I multiplied by R plus uppercase R, and this is equal to E. So the net current, that is going to be E, the EMF of the DC source, divided by RT plus a smaller case r. Now why did I represent that as R sub t? That is as a result of the fact that it's possible for you to have more than one resistor within the external part of a circuit. Like in this case, we have this and these and this one. So that is more than one resistor. So you would actually need to find out what will be the total resistance within that. Okay, so we need to do that. Now I might just well call this as R1 and let's call this R2. So this is going to be R3 and this resistor we're going to call it R4. Now we need to find out what is a resultant for this parallel connection. So I'm just going to call that as RP1. That is the resultant of the first or the only parallel connection within this circuit. So you could easily find that, but this 1 over 3 plus 1 over 7, that is raised to the power of -1. So we have that. So this is going to be 1 divided by 3 plus 1 divided by 7. So that gives us 2.1. Now 2.1 ohms is actually the resultant of this. So as it is, we're going to have something like this. And we would have this battery source in this form. So this is the 4 ohms, this is the 6th, and this is 2.1. So since we have these resistors in series, we're actually going to add them linearly. So that is going to give us the total resistance for this circuit. So that is going to be 6 plus 4 plus 2.1. Now 6 plus 4, that gives us 10. 10 plus 2.1, that is going to give us 12.1 ohms. So we have the total resistance within this circuit to be 12.1 ohms. Now having got that, we can now go back and find what is the net current within this circuit. because we already have what the internal resistance is. This is the internal resistance. And we also have the EMF of the DC source, which is 20 volts. So the net current, which could also be represented as IT, is equal to E, which is 20 divided by RT, which is 12.1. And this is plus the small r. Small r is 1.2. So let us see what that gives. That is 20 divided by 12.1 plus 1.2. So that gives us 1.50 or 1.5 in short. So that is 1.5 amps. This is going to be the total current within this circuit. Now next up, we need to find what is the current that is passing through each resistor in this place. So how can we do that? How can we find the amount of current passing through the 3 ohm resistor and the one that is passing through 7 ohm resistor? How can we do it? Now the only way to do that is to use the method of the loss voltage as well as the terminal voltage. So we need to find those ones first. Now we know that loss volt I might write it as V sub L. That is going to be I multiplied by small r. Now I sub T, that is 1.5. And this should be multiplied by R, which is 1.2. And so let us see what that gives. So that gives us 1.8. So as it is, we have 1.80 volts. Now we know that the EMF of the DC source is 20 volts. And this is actually split into the external voltage, which is also called as a terminal voltage. I might write it as I'm representing it here as V sub X. And we have V sub L as a loss volts. So I have gonna write it over here. VL, which is a loss volt, that is 1.80. Now we know that Vx is therefore going to be E minus V sub L. Now we know what V sub L is. That is 1.8, and E, that is 20. So that will be 20 minus 1.80. So what is that going to give us? So that should give us 18.2. So this is 18.2 volts. So this is what we have. The remainder of the EMF of this DC source left to flow through this external circuit is actually 18.2 volts. That is actually what is available. So this is what you need. Now, by that, you know what the terminal voltage is. So the terminal voltage, that is Vx, and that is equal to 18.2 volts. The loss volt, that is 1.80. Now we are going to use the terminal voltage to find out what will be the current through all these ones. So how can we do that? Now we know that this is going to be the negative terminal of this battery, and this is going to be the positive terminal. So as it is, current will go through this direction. Current always moves from the positive terminal to the negative. So this is going to be IT. Now IT is going to get multiplied with R4 to give us what will be V4. Now V4, that is the voltage over the 4 ohm resistor. So let us see what that is going to be. Now we have IT multiplied by R4. Now we know what IT is. IT is 1.5 and R4, that is 4. So if we multiply 1.5 by 4, that will give us 6. So we have 6.0 volts being dissipated over R4. Now if you have that, what is going to be left? Now you know that what was available for the external part of the circuit was 18.2 volts. Now we have 6 volts being depleted away from this. So that is going to be 12.2 volts. So 12.2 volts will be left after some amount of voltage has been dissipated over V4. I might just well write what V4 is here. So that is 6.0 volts. So this is what we have. Now, we know that as a current enters through this place, there is actually going to be a split. So we would actually have one current going through this. I might call this I2 and another going through this. So let us call this I3. Now, we might also call I sub t as I1, whichever way you want to call it. There is actually no difference with that. Okay, so we know that IT, which is the same thing as I1, will be equal to I2 plus I3. Now, as we come to the end of this junction, there is actually going to be a reunion of the two splitted currents, and so that is going to get added together. And so the current that should go through the 6 ohm resistor, that is still going to be I1 or IT, right? So let us find what that is going to be. If we are able to tell that, then we would actually be able to find what is going to be the current over R2 as well as the current through R3 very easily. So let us try to do that. Now we know that V1, that is going to be I1 or IT, which is the same thing, multiplied by R1. Now we know that I1 is 1.5 and R1, that is 6. Now if you multiplied 1.5 by 6, that will give you 9. So we have 9.0 volts. So that is going to be V1. V1, that is 9.0 volts. Now, if we have this, we know that Vx, which is the terminal voltage, that is the voltage left for us to use within the external part of the circuit. That is given as 18.2. Now, that will be dissipated over the first resistor, which gives us the terminal voltage or the voltage drop over of the first resistor, which is represented as V1. We're also going to have the 1 over this one, which is a parallel connection. Let me represent it as VP. Then this other one, which is V4. So we need to find what VP is. If we are able to tell what VP is, we could use that to tell what is going to be the current passing through 3 ohm resistor and the 7 ohm resistor. So let us go back. Now for Vx, we know we have a 18.2 and we have V1. V1 is 9.0. So we are looking for VP and V4, that is 6.0. Now if we added 9.0 to 6.0, that is going to give us 15. So this is going to be 15 and that is plus V sub P. So V sub P, that should be 18.2 minus 15. So let us see what that gives. 18.2 minus 15. That is 3.2. So we have 3.2 volts present and left to actually go through this particular parallel connection. And that is actually reasonable. We know that for parallel connection of resistors, the voltages are actually the same. So the voltage passing through R2, which might well be called as V2, is the same thing as the voltage passing through R3, because both R3 and R2, they are actually parallel to each other. So that is actually going to come out very easy for us now. Now what I'm going to do, I'm going to use this information to find out what will be the individual currents that will pass through R3 and R2. So let me wipe this out. Yeah. So we know that for parallel connections, the voltages are basically going to be the same, right? So VP is going to be the same thing as V2 and is the same thing as V3 if you wanted to find it. So let us start with this first one. Now, VP is equal to V2, right? So what is V2? V2, that is going to be I2, which should be the current passing through the 3 ohm resistor or the second resistor. And that is multiplied by R2. We know what VP is. VP, that is 3.2 volts. Then over here, we have to find I2. Now R2 is what? That is 3. So I2, that is going to be 3 over 2 divided by 3. So this is divided by 3. Now that gives us 1.07. So this is going to be 1.07 amps. So that is what we have for I2, right? Now what is going to be I3? We know that VP is the same thing as a V3. Now V3 should be I3 multiplied by R3, right? So I think I need to wipe this out. Yeah. So we know that VP is 3.2. And I3 is basically what we are looking for. R3, that is 7 ohm. So that is going to be 7. So let us see what I3 is going to be. I3, that is going to be 3 over 2 divided by 7. So that is 0.457. So that is what we have for, well, that is what we have for I3. So everything comes off easy now. We have been able to find what is the terminal voltage and also to find what I2 is. I2, that is 1.07 amps. And I3, that is 0.457 amps. Now, how can we know that we are actually correct by the answers we have gotten? Now, we said I sub t is the same thing as I1, right? Now, we said that is the same thing as I2 plus I3, right? So what that means, if we are able to add these two figures and find 1.5, and we are really on track. That is going to be correct. So let's see what that's going to give. Okay, so we have 1.07 plus 0.457. That is actually gonna give us the answer. So this is 1.07. So this gives us 1.527. 1.527, which is approximately the same thing as a 1.5 to 1 decimal place. So this is actually correct, and we have actually solved every question within this problem.